There's one more type of example that's slightly more complicated, but the same principles still apply. So we have a puppy and it's running around in a circle. We've all seen them chase their tail. He's very fast and his position changes with respect to time, given by the parametric equations x equals cos t and y equals sin t. Because these are cos and sine functions, we're going to find his position after 0, pi on 4, and pi on 2 seconds. He's running in a circular motion, so you can imagine this kind of like that angle. So instead of using 0, 1, 2, 3, and 4, we tend to use angles or radians here. Let's find his position for 0, pi on 4, and pi on 2 seconds. Our equation for x is cos t, and our equation for y is just sin t. So for t equals 0, well, cos of 0 is just 1. For t of 0, y of sin t, that's going to be, well, sine of 0 is just 0. That will give me my first coordinate point, 1, 0. So after 0 seconds, the puppy is at the point 1, 0 on my xy plane. For pi on 4, cos pi on 4 is 1 over root 2, or root 2 on 2. The same as sine pi on 4. I'm just going to leave it as 1 on root 2 for both, but feel free to rationalize, especially in an exam. Lastly, for pi on 2 seconds, I have cos pi on 2. That's 0. And sine pi on 2, that's going to be 1. So my final coordinate point for these 3 times is 0, 1. Our next job is to again convert the equation from parametric into Cartesian form. This is where the change happens. You're going to use a Pythagorean identity. Primarily we have cos and sine to help you eliminate t. Let's look at the Pythagorean identity that I know. I know that sine squared t plus cos squared t equals 1. Oh, hold up. I know that x equals cos t and y equals sine t. So I can substitute x in wherever I see a cos and y in wherever I see a sine into my Pythagorean identity. Let's have a look what we'll get. Well, if sine t is y, I have sine squared in the original, so I have y squared. Plus, let's substitute x in for cos t. I'll get x squared because I have cos squared, and all that equals 1. Now, this is the equation of a circle with center 0, 0 and radius 1. And that, to me, seems similar to the coordinate points that we were starting to get when we were doing our table. Right, let's use both of these to sketch our graph. Remember, we have to show the direction that the puppy is moving, usually with an arrow. Let's start with our table of points here. When time is 0, my xy coordinate is 1, 0. When time is pi on 4 seconds, my xy coordinate is 1 on root 2 and 1 on root 2. That's going to be somewhere up here. And then lastly, we have time equals, or t equals pi on 2. That will be 0, 1, all the way up the top. Now know that we get bigger and bigger. So time 0, pi on 4, pi on 2. So this tells me the direction that my puppy is moving, and it is anti-clockwise, starting from the x-axis to the y-axis. Remember, it's also a circle. Y squared plus x squared equals 1. So my puppy's going to run all the way around this circle with a radius 1 and center point 0, 0. So put your arrows on, and that's the graph. Lastly, how long does it take the puppy to run around one circle? Now, we know here it takes the puppy pi on 2 seconds to run just a quarter of the circle, from the x-axis positive to the positive y-axis. So to go around the whole circle, I can just times this by 4. So the puppy will take 4 times pi on 2, that is 2 pi seconds, to run around the whole circle. So that's really like 2 times 3.14, so just over 6 seconds to do a full circle. Notice this is also the period of the function. So again, this relates to 15F. Complete your